Hi, I'm Dr. Archana. Today we will study the topic solid state chemistry. It is a very important topic from board and competitive exam point of view. We'll first try to strengthen the fundamentals of this topic and then we'll move on to the application part or numericals. Once we understand the fundamentals well, we can solve or tackle any numerical from this topic. So let's get started. Matter comprises of different phases like solid, liquid, and gases. Among this, solid is one of the important phases. Materials occur in solid form. What a striking feature of a solid is its ability to have solids have an ability to have definite shape and size. Also, they have low compressibility. That means they cannot be easily compressed. And high density. High density we know by being any solid. They have less vapor pressure as compared to the other phases. So basically solid, liquid and gases are the various phases which can be distinguished on the basis of their thermal energy. That is one thing. And second is intermolecular forces. So let us move on to the broad classification of solid. First and foremost, they can be classified based on the packing of constituents. Like they can be comprised of various particles or they can be comprised of various molecules. So based on the packing of the constituent particles, they are classified into two types. One is crystalline solid and second is amorphous solid. So we will tabulate the various properties of crystalline and amorphous solid. And discuss the various properties one by one. So, the first and foremost important property is crystal geometry. So, crystalline solids are basically have a very definite shape because of the regular arrangement of particles in 3 dimension. Whereas the amorphous solid, they do not have a definite geometrical shape. Why? because they have haphazard or disorderly arrangement of particles. Important point is the melting point. So the crystalline solid have a sharp melting point, whereas amorphous ones do not have a sharp melting point. For example, if you speak about ice, so ice everyone knows, and it is a general information that it will melt if the temperature goes above 0 degrees Celsius. So it is a crystalline solid. Whereas if you consider plastic or glass, they do not have a sharp melting point. Third most important aspect is crystalline solids have a plane of symmetry, and they also have a center of symmetry, and they have an axis of symmetry. While none of the elements of symmetry are possessed by this uh, amorphous solids. If you want to have an example, let us consider this example. So this is front and back face of a crystalline solid. So if I consider, then this can be called as a plane of symmetry. This is the center of symmetry for this particular crystalline solid, and we can have three axes. So this is what we mean by plane of symmetry, center of symmetry, and axis of symmetry. In depth, we'll study about the various elements of symmetry as we proceed further in this chapter. So this crystal lattice has basically three axes of symmetry and three planes of symmetry. Further, the crystalline solid have anisotropic property. What do we mean by this? And amorphous solids have isotropic properties. They have long range order, whereas amorphous solids have short range order. Let me give you an example to elaborate or illustrate this particular point. Suppose this is the constituent atoms of the various crystal lattice. So if I draw a line is in this direction, it will encounter different constituent particles. And if I draw a line in this direction, it will encounter different constituent particles. That means if we speak about the various properties like refractive index, conductivity, thermal and electrical both, mechanical strength, so all these properties are different in different direction. That is, they are anisotropic, not same in all the direction. Whereas for amorphous solid, which is disordered solid, which is also known as pseudosolid. So these are basically known as true solids, whereas amorphous solids are known as pseudosolids. They are isotropic in nature.